Um, we're going to start our new chapter, chapter 9 today. This is impulse and momentum, so lesson 1. We're going to do our normal 2 problems. This first one reads, a lump of clay with a mass of 5 times 10 to the negative second kilograms is thrown towards a wall with a velocity of 3 meters per second. The clay bounces off the wall with a velocity of 0.5 meters per second. What is the impulse on the clay? Sorry, I'm getting used to this new pen. So what they're asking us for is they're asking us for impulse. Yesterday we learned that impulse was equal to force times the change in time and was also equal to change in momentum. So our final momentum minus our initial momentum. We are given 2 velocities and a mass. So real quick, I'm going to write those down. I'm given a mass, and this is 5 times 10 to the negative 2, so 0.05 kilograms. I have a velocity initial, and we're going to call him, that was 3 meters per second, and a velocity final, which is going in the opposite direction, so I'm going to assign that a negative 0.5 meters per second. Now I don't have force and I don't have change in time, so I'm not going to be able to find my impulse doing force times change in time, and I'm going to have to find the change in momentum. So I know that momentum, P, is equal to M times V. So I'm going to find my final momentum first, and in that I would just take 0.05 times negative 0.5. I'm going to end up taking that, and I'm going to subtract my initial momentum, which is going to be 0.05 times 3. So I'm going to get 0.15 over here, and negative 0.025 here. And when I subtract that, I'm going to get negative 0.175. And I'm taking mass times velocity, so my label is going to be kilograms times meters per second. And that is going to be my impulse. That's a terrible circle. I'm sorry, guys. Make a better one. There you go. Also, sorry, I erased the unit. Still getting used to this new pen. Anyway, that one's pretty easy. Here's our next one. Again, this one's not too bad. Here we have A, and then we're given a mass, so I'm going to write that down. Mass is equal to 6,110 kilograms. Traveling at, and then I'm given a velocity initial of 20 meters per second. And it can be stopped in 24 seconds. So when it says stopped, I need to recognize that that is a velocity final. So meters per second, 0. And then I'm given a change in time of 24 seconds. By gently applying the brakes, if the driver slams on the brakes, then the bus can be stopped. So stop again, same final velocity. And I'm given a different change in time, 3.9 seconds. What is the average force? So again, we're going to use that same kind of base equation we started with yesterday, or last problem. We have force times change in time is equal to change in momentum. So we know that because momentum is equal to P, or momentum is P, and is equal to mass times velocity. If I have a velocity of 0, my momentum is going to be 0. So in both of these instances, because my final momentum has a velocity of 0, I'm going to have a final momentum of 0. So in this case, our force is going to, for change in time times force, is going to be equal to just negative momentum initial. So I'm going to have to do this twice because I have 2 different times and I'm trying to find 2 different forces. So the first thing I can do, which will be the same for both, is the initial momentum. which will be my mass, so 6110, times my velocity. Both of those are already in SI, so that is going to give me 1, 2, 2, 2, 0, 0. Sorry, that one looks terrible. And that would again be in kilograms. That's going to be negative, so that would be kilograms meters per second. And that is going to be equal to my force times my change in time. So I'm going to do this twice. For the first one, we'll just go 24 seconds. And I would take this and I would divide by 24. And I'm going to get a net force of negative 5,092 newtons. So that is going to be one of my answers. In my other answer, I'm going to use this stuff from right up here, except I'm going to have 3.9 as my time. So I'm going to take this divided by 3.9, and I'm going to find out the force in that situation is equal to negative 31,333 newtons. So I have two answers for this one. Again, terrible circle. I'm sorry. But yeah, I'm hoping this section is not too bad for you guys. This looks to be not the worst chapter we've done. So I hope you guys are getting it, and let me know if you have questions. Bye.